Okay, so we're going to do problem solving with quadratic function. I haven't written out the whole problem just because I'm very slow at writing, but I'll read it. And this is kind of the key pieces of what we have. It says a construction worker repairing a window tosses a tool to his partner across the street. Sounds very dangerous, but what we'll do, it's never a bad idea to kind of mimic the situation. So we got our two guys here. He's across the street. They also look like giants in the size of a building here. But he tosses a tool across the street. And what they're really trying to outline here is you're getting this parabola shape. Okay? And that's what they're trying to emphasize with this question. The height of the tool above the ground is modeled by the quadratic function this, which I've written it out. H at t is equal to blah. Where h is the height, or h at t I should say, is the height, and t is time. So depending on how much time has passed, the tool's at a different height every second after he releases it. The very first question asks us, hey, how high is the tool above the ground after 2 seconds? Okay, so how high? Whoops. How high after 2 seconds? Okay. What we need to figure out is this value giving us a quantitative value for height or a quantitative value for time? And time, yeah. They've given us a unit of seconds, so we know we're time. And because of the function notation, we know we're replacing t in that equation. So instead of h at t, we're going to say h at the number 2, because that's 2 seconds, is equal to negative 5, 2 squared plus 20 times 2 plus 25. We'll kind of try to jump through this quickly. This becomes negative 5 times 4 plus 40 plus 25. This becomes negative 20 plus 65, which is 45. Height in meters, actually. I should make sure I didn't put a unit there. Meters. So at 2 seconds, and you could give this a coordinate. The x value is 2. Okay. The y value is 45. So this is actually like in a coordinate here. And after 2 seconds, the height is 45 meters. 45 meters is very high. So they are like on the top of buildings here in this question. How high above the ground is the window? Tosses a tool to his partner across the street. Worker repairing a window. Okay, a little vague. They're inferring here. So the next question asks you, how high is the window here? So we're going to zoom out a little to give us some space. I've drawn them on top of a building, but after a second glance, it sounds like what they're saying is this guy's actually hanging out the window, so he's far more dangerous of a situation than we anticipated. Here are two guys, and he's tossing it. The question's saying, how high is this window? What that usually means is that is commonly known as like the y-intercept. Where is this toss starting from? So think of this like our y, and this is our x. The ground might be the x-intercept here, and the beginning of the toss, okay, especially because we're in time, and time is almost always going to be on the x-axis. And that's because when we represent things on a graph, we usually put the independent variable on the x-axis and the dependent variable on the y-axis. I definitely didn't spell that right. Dependent variable on the y-axis. Think about time. Almost nothing we do influences time. Tactically, if you travel extremely close to the speed of light, you can slow time down. We're not talking about that in this class. So there's nothing we do that influences time. If I throw a hammer, time still passes. If I don't throw the hammer, time still passes, okay? But as time passes, that does influence the height of the hammer. We know that happens. So this is the starting point. In other words, they're asking for the y-intercept. So I actually don't have to do any formal equating here. I got to just take a second look at my equation. So h at t is written the negative 5t squared plus 20t plus 25. If I take a look at this, I gotta go, what kind of form do I think I'm in? Am I in standard form? Am I in factor form? Am I in vertex form? By looking at this, do you have any idea which of the forms we're using?
We're using standard.
Yes. Yes, exactly. And what's good about standard form is it actually gives us a y-intercept in standard form. And the y-intercept is the c value. So in this case, the very last digit here, 25, that is the height. So he was at 25 meters, okay? Which means after 2 seconds, he threw it 20 meters in the air. That's absurd. I'm pretty sure he could not throw it that high. Another way you could have solved this, Nathan, is we assume in terms of time, t is actually 0 when he starts, right? He hasn't thrown the hammer, so no time has passed. So we might say h at 0 is equal to negative 5t squared plus 20 times 0 plus 25. You're going to notice we're going to get the exact same thing. Oops, that should be a 0. 0 squared is 0 times negative 5 is 0. 0 times 20 is 0. So we get 0 plus 0 plus 25 gives us 25. The exact same we did, we just didn't have to do that formal equating. We could take a look at it in standard form and get the same information. Okay? So we know he starts at 25 meters above the ground. That's pretty high. If his partner misses the tool, when will it hit the ground? This is where we would use factoring or the quadratic equation normally. Essentially what they're saying is, hey, if he misses, when does this happen? Now, technically, parabolas go back, right? But the problem is time is our x-axis. And let's take a guess here. Let's say maybe that value would have been an x value of negative 3. Does it make sense that the tool was on the ground at negative 3? Unlikely. We'd literally have to go backwards in time, which is not something we know how to measure, really. So we're not going back in time for this question. We're just trying to go forward in time. So that negative 3 is kind of irrelevant. And as you start to factor and use quadratic formula, you'll get 2 answers to equations, and you have to use logic to make sure your answer makes sense. You don't want to say, after he threw the hammer, 4 seconds before he threw it, it was on the ground. It doesn't really make sense. We'd only look for the positive value in this case. Because we haven't really talked about quadratic formula or factoring, this ends up being a bit of a trial and error question again. We know after 2 seconds it was 45 in the air. So we end up we got to start trying some equations where h at t, which is exactly what we were doing before. So, I mean, I'm going to jump out here and throw the number 5 out and see if that gives us a negative or a positive value, and we can start to hone in. Instead of going step by step, we're going to take some educated guesses and jump our way across time. So when the time is 5, that gives us negative 5 times 5 squared plus 20 times 5. Sorry, I could really expand this page here. That's a little better. And we're left with negative 5, negative 5 times 25 plus 100 plus 25. Ooh, I think I got it. Negative 5 times 25 is negative 125 plus 100 plus 25. That gives us 0. So our height is 0 meters at 5. I did a pretty good educated guess in this case. It so happens that it would hit the ground after 5 seconds. If you didn't guess it right on the first time, what you need to do is evaluate the y value. If you got like negative 12, that means you've gone too far forward in time. That means we're somewhere down here, and we'd have to take a time that was, a little farther back. If we were still in the air at maybe positive 12, that means we got to move a little farther forward in time to figure out when it would hit the ground. Okay, so depending on the y value you get educated guesses from there.